Welcome to the deep dive. Okay, so if you're someone who, hears blockchain thrown around and you nod along, but maybe you're not totally sure about the actual mechanics behind it, well, this deep dive is definitely for you. We've gathered some really interesting source material today. It gives us basically two key things. First, a really simple kind of physical analogy to get our heads around decentralized records.
Yeah, like a tangible way to picture it.
Exactly. And second, we're going to take that understanding and apply it straight away to a pretty big mobile crypto project that's out there right now, Pi Network. Our goal here is pretty straightforward. Take these concepts that sound complex, things like immutable ledgers, distributed networks, and we'll break them down, make it clear, structured.
Make it make sense.
Right, so by the end, you won't just know the definition, you'll actually grasp the thinking behind projects like Pi that are trying to, push crypto out to more people.
Okay, let's unpack this then. I think what's great about the sources is how they start with the foundations. You really need to get the why is this secure part before jumping into how are they actually using it.
Makes sense.
So we'll connect those dots from the, let's say, the theoretical strength of this chain idea to the real world challenges of getting a new network like this adopted and used economically.
All right, so let's start right at the beginning, at the base level. The analogy our sources use asks you to imagine building a giant tower of blocks with a whole bunch of friends.
It's a fantastic image, actually, because it makes something digital feel physical.
Yeah.
So what are these blocks in our tower?
Good question.
They're just records. Simple as that.
Yeah.
Records of events. Could be anything, really. The analogy mentions finding treasure or lending a soul.
Or, in the real world, usually money changing hands.
Yeah.
Financial transactions.
Exactly. Each block is like a single slip of paper dated detailing one or more things that happened, a verifiable record.
Okay, but it's not just a messy pile of these paper slips, is it? The sources really stress the structure. For this tower to stand up, each new record, each block, has to be firmly connected, laid right on top of the one that came before it.
Right, you can't just wedge a new one in the middle somewhere.
No sneaking things in later.
And that stacking, that chronological order, that's what makes it a chain. It locks the sequence of events in time. What happened 5 minutes ago is structurally tied to what happened 4 minutes ago.
And it all starts somewhere, right? There has to be a first one.
Precisely. You look at that very first paper slip, the one that kicks the whole thing off the first block, they call it, that sets the entire history. The validity of every single block stacked on top depends on that starting point.
Huh. Wait, so the security isn't coming from, like, a padlock or a central bank vault.
Yeah.
It's baked into the structure itself, the difficulty of rearranging the tower.
That's the core idea. It's pretty clever, actually. The firmness of those connections, that's what gives it immutability. That's the fancy word for it.
Meaning you can't change it easily.
Right. The sources explain it like this. To change something written on, say, the 10th block down from the top, you couldn't just erase it. You'd literally have to tear down the entire tower above that block.
Whoa.
And then rebuild every single block that came after it perfectly in the right order.
Okay, that sounds like a ton of work. Is that related to why we hear about Bitcoin mining using so much electricity?
Yeah.
Is it the energy needed to try and, like, rebuild part of the tower if you wanted to cheat?
You've got it. The difficulty in rebuilding that tower, that's the mathematical lock.
Yeah.
The computational work involved. You'd have to pour so much energy and time into altering just one block that by the time you even got close, the rest of the network, all your friends building the tower together, they would have already added like 20 new legitimate blocks on top.
Mm-hmm.
The honest collective effort always outruns any attempt to fifth the cast.
Ah, okay. And then there's the other T, transparency.
Yeah.
That reinforces the security too, right? The sources call the blockchain a large notice board.
Yeah, everyone involved can just look at the whole tower anytime they want and see exactly what's written on every single block.
So verification is public.
It's crucial for trust. If you claim Block 50 says you lent me, 10 coins, but I look at the public notice board and everyone else looks, and Block 50 clearly says you found treasure, well, the network immediately knows who's not being truthful.
Because the record is right there, visible to all.
Exactly. So you connect those two things, the rigid structure, the difficulty of changing it, and the complete visibility. And that's where the trust comes from. It ensures the information, especially about money, is supposed to be safe and accurate.
Okay, I think I'm getting the tower analogy. It's secure because it's hard to change and easy for everyone to check. But how do you take this complex, maybe energy-intensive idea and get it working for millions of people on their phones? Which brings us neatly to the case study. Pi network.
Right. So, moving from the theory of the tower to a real-world project. The sources identify Pi Network as, well, a blockchain crypto project. But their stated aim isn't just another coin. It's specifically about driving broader crypto adoption, making it accessible.
And the background is interesting, too. It came out of Stanford University, launched by PhD students back in 2019. So it has that academic origin.
It does. But their main selling point, the thing that really sets it apart from, say, Bitcoin mining, it's completely different.
How so?
Well, think about traditional mining. You need serious hardware, warehouses maybe, consumes tons of power. Pi Network offers what the sources describe as a simple and ecological way to mine.
Simple how? Like really simple.
Apparently, yes. Just open the app on your smartphone, press a button once a day, that's it. No special gear, supposedly minimal battery use.
Wow. Okay, that's a massive difference. It lowers the barrier to entry dramatically.
Right.
Almost anyone with a smartphone can potentially participate.
Precisely. And here's where their strategy gets, well, quite interesting from a growth perspective. They built in a network effect.
Meaning?
Users are actually incentivized. They can mine Pi coins faster if they actively bring more people into the network through referrals, invitations, that sort of thing.
Ah, so your mining rate depends partly on how many people you've invited.
Exactly.
Yeah.
It's a design choice that directly links distributing the coin to growing the user base. It's meant to accelerate growth. The sources show this focus was there from the start.
And they mention specific incentives, right? Like using someone's referral code gives you a boost.
Yes, the material gives an example code and mentions a benefit like a 25% increase in mining speed. We won't repeat the specifics here, but the fact that it's spelled out so clearly shows how central that referral model is to their plan for getting scale fast.
Okay, so if growth relies heavily on this network effect, what's the current situation? Where's the project now, and what do people need to do if they want to join?
Well, the sources indicate Pi Network is in the process of launching its main network, its mainnet. This is a pretty critical phase, moving from just accumulating potential coins in an app to having a live, functional blockchain ledger where transactions can actually happen.
So for someone new wanting to start, what are the steps? Download the app, presumably.
Download the mobile app, yes. And you generally need an invitation code from an existing user to sign up. We saw an example code in the source material.
And using a code gives that mining speed boost we talked about.
That seems to be the promise, yes. A mutual benefit for the referrer and the new user. But here's where it gets quite strict and maybe a bit unexpected for some people in crypto.
What's that?
Long-term participation, actually keeping the Pi you've mined, requires passing KYC.
Okay, let's pause there. KYC, that's know your customer, correct? Not know your credit, as sometimes gets mixed up. It's about identity verification.
Exactly right. Thanks for clarifying. Know your customer. It's the standard process banks and financial services use globally to check you are who you say you are.
And Pi Network requires this.
Mandatorily, according to the sources. After about 30 daily mining sessions, you have to complete this KYC process. And crucially, you must have registered using your real name. It has to match your official ID documents.
That's interesting. For a project using decentralized blockchain tech, which many people associate with, anonymity or pseudonymity, why such a strong emphasis on real-world ID?
It's a very fair question. The sources don't explicitly state the why in depth, but they do highlight the consequences of not complying. There's apparently a significant penalty. You could lose a chunk, like 20% of your mined Pi, if you registered incorrectly or fail the KYC verification.
A penalty, wow.
Yeah. So what does that signal? It strongly suggests they're prioritizing regulatory compliance, trying to prevent frauds, stop people creating tons of fake accounts, bots to unfairly mine coins. They seem to be aiming for a legitimate, identifiable user base for their economy.
So it's this tension then, using the decentralized tower structure, but overlaying it with centralized identity checks. And you mentioned an economy. Are they actually trying to build something where Pi can be used?
It seems so. The sources briefly mention something called the PiBazar, described as the first community bazaar in Europe.
A marketplace.
Yeah, basically a place where people can list products or services and accept Pi cryptocurrency as payment. It points towards that next crucial step, moving beyond just mining a token to actually using it for exchange, creating a real ecosystem.
Okay, so we've covered quite a bit today. We went from that simple visual analogy of the secure blockchain tower built on that idea of being hard to change, easy to see.
Immutability and transparency, yeah.
Right, all the way through to the practical application in Pi Network. Their strategy of super easy mobile mining driving growth through network effects.
And that very strong requirement for know your customer, for real identity verification.
It's quite the journey from theory to practice.
And if we pull back to the bigger picture for a second, the source materials definitely touch on the ongoing challenges. Crypto adoption is still tough. Market volatility is a huge factor. One article noted a pretty sharp price drop for PI recently, like over 18% in a day.
Ouch.
Yeah. So the ultimate hurdle isn't just building a secure tower, the tech itself. It's getting that technology widely used, stable, economically valuable, especially when the financial markets around it can be so wild.
Absolutely. Which I think leaves us with a really interesting final thought for you, the listener, to chew on based on everything we've discussed from the sources. Given that a core appeal, or at least a historical principle of many decentralized systems, was this idea of permissionless access, maybe even pseudonymity, how sustainable is Pi Network's approach? This blend of a decentralized blockchain structure with an absolutely mandatory, quite strict demand for real-world identity verification via KYC.
Is it the necessary trade-off to achieve mainstream acceptance and legitimacy?
Or does it fundamentally chip away at the original ethos of that open decentralized tower they're trying to build? Something to think about as you continue exploring the world of blockchain and crypto.